This is lesson number 73, solving exponential equations. The essential question is, how do you solve exponential equations? And so we have about 8 or 9 slides that are going to take us through being able to solve different types of exponential equations. So let's get started. So the first thing you have to know in order to solve exponential equations is the property of equality. So first of all, remember that in an exponential function, the exponent is a variable. So anytime we are looking to solve an exponential equation, we are looking to solve whatever that variable is that is the exponent. It's not going to be like 2x plus 4, we are always looking at whatever that exponent is. So the property of equality says that if b is greater than 0 and b doesn't equal 1, remember b being our base, then b to the x power is equal to b to the y power if and only if x is equal to y. So if 3 to the x power is equal to 3 to the 5th power, then x is equal to 5. And because the problem says if and only if, that means we read it forward and backwards. So that means that if x is equal to 5, then 3 to the x is equal to 3 to the 5th. As I keep going, please do make sure that you pause to write down everything so that you can have it in your notes accurately. So now that we know this property of equality, let's apply this property of equality to some problems to solve them. So we have a couple of examples, so let's look at them. The first example says that 2 to the x is equal to 8 to the third. Now, here's the issue. When we talk about the property of equality, the base for both of them was b. But in this case, we have one base that is 2 on the left and then one base that is 8 on the right. So in order to solve, we have to get the bases to be the same on both sides. So on the left, we have 2. 2 is a prime number. Let's leave that as 2 to the x. On the right, we have 8. Well, we know that we can rewrite 8 in terms of 2 because 8 is equal to 2 to the third. So I'm going to rewrite 8 as 2 to the third. And then I need to keep that additional third because the problem is 8 to the third. So the only thing I did or rewrote was the 8, and I wrote it as 2 to the third. So now I need to use my properties of exponents here. And so that means that I'm going to have 2 to the x is equal to 2 to the 3 times 3 is 9 because that's my property of exponents. And now I can use the property of equality. If the bases are the same and the exponents are the same, so that means that x is equal to 9. So if you want to, you can go ahead and pause right now and then work on problem B and then come back. Or if you need to see another example, then I'm going to work that one now. Okay, so again, my bases are different. My base on the left is 9. My base on the right is 3. 3 is already a prime number, so I'm going to rewrite 9 in terms of 3 so that I know that 9 can be rewritten as 3 squared. So that's going to be 3 squared, and that replaces my 9. And then I have 2x minus 1. So notice that when I replace a base, whatever that exponent that I'm using or whatever that power formula that I'm using, I'm putting it in parentheses. And so that's going to be equal to 3 to the 6x. So again, my rules for exponents, this is power to a power, so I'm going to multiply. So I'm going to have 3 to the 4x minus 2 is equal to 3 to the 6x because I really have to distribute. 2 times 2x is 4x and 2 times negative 1 is 2. So now my bases are the same, and when my bases are the same, then my exponents can be equal. So 4x minus 2 is equal to 6x. I'm going to subtract 4x from both sides. So negative 2 is equal to 2x. Divide both sides by 2. So x is equal to negative 1. And that's it. So in order to solve, you have to make sure that your bases are equal. So let's look at a couple of more examples. So now we have 4 to the 2n minus 1 is equal to 64. So again, we got to figure out, okay, what are we going to do to get the bases to be the same? I have a 4 on the left. Is it possible for me to write 64 in terms of 4? Or do I need to change both of them to get a value? Well, I can rewrite 64 in terms of 4. So on the left, I'm going to keep it 4 to the 2n minus 1. And then on the right, I know that 64 is 4 to the third. So now my bases are the same. So my exponents can be the same. So 2n minus 1 is equal to 3. Add 1 on both sides. So 2n is equal to 4. Divide both sides by 2. So n is equal to 2. Okay. Now, let's say you didn't know that 4 to the third was equal to 64. What if you were just like, oh my gosh, I didn't know my stuff that you must know, Cole. I don't know my powers of 4, but I do know my powers of 2. And I do know that 2 to the 6th is 64. Well, let's look at it and see what happens if we use 2 to the 6th. So if I'm using 2 to the 6th for 64, that means I have to use, I'm going to put a little squiggly line here. That means I have to use 2 squared for 4. So I'm going to rewrite 4 as 2 squared to the 2n minus 1. And that's going to be equal to 2 to the 6th. So again, I know that 2 to the 6th is equal to 64. So I have to rewrite both bases in terms of 2. So then on the left side, what do I end up with? I have to multiply. I'm going to get 4n minus 2 is equal to 6. Add 2 to both sides. So 4n is equal to 8. Divide both sides by 4. So n is equal to 2. Well, isn't that awesome? I got the exact same thing. So it doesn't matter what your base is as long as your base on the left and your base on the right are the same. So you just have to make sure that they are the same and then you're good. Okay, so let's look at B, or you should actually go ahead and pause it and try to do B on your own, but I'm going to go ahead and do it. So my base on the right is 5, so I need to try to write 125 in terms of 5. So I'm going to keep the left, and I'm going to rewrite 125 as 5 to the third. Remember, I'm putting that in parentheses. So 5 to the third to the x plus 2. So now I need to distribute over here because this is power to a power. So I'm going to have 5 to the 5x is equal to 5 to the 3x plus 6. So my bases are now the same. So now my exponents can be equal. So that means that 5x is equal to 3x plus 6. I'm going to subtract 3x. So 2x is equal to 6. Divide both sides by 2. So x is equal to 3. Okay. All right, so let's now look at a word problem example, which I know we all love.